Hi, welcome back to section 2 of the third week of Echo 360. As we had indicated earlier, what we're going to do today is cover some of the highlights of chapter 5, with one exception. The few pages about the Edgeworth-Bowley box we're going to skip. It isn't that they're not important, but they are a little bit more complicated than what we need for this particular semester, and you will be covering them, those of you who are economics majors, in your intermediate microeconomics probably, and if you happen to take some other courses in international trade. So the 2 or 3 pages about the Edgeworth-Bowley box we are not going to deal with. The other thing before we get started is that probably I should mention it, I'm sure it's already clear, but the packages that we have for doing these things really have no capability for any editing whatsoever. So it's just in essence really a first take with absolutely nothing to do about doing any corrections if something goes wrong, and unfortunately sometimes they do. I'll just have to start all over again. So for example, this particular in this particular case I'm mentioning it because this is really the 4th take. I mean, all of a sudden things just go berserk and then I wind up with nothing. So I hope you'll put up with me just in case the frustration comes across. The other thing that I wanted to mention is that this chapter in particular is not really about trade per se, as you have noticed probably if you have looked at it. It is, however, very important in the sense that it will act as a quick refresher for some of you, or maybe a brief primer for those that might have forgotten all of their economics. So these are tools that we're going to have to use for week number 4 quite a lot, and that's why it's important to introduce them right now. Actually, so many of the textbooks take it for granted that people are very familiar with all of these tools, and so they do not even bother to devote a chapter. I think this book has done a good thing by devoting a chapter to it in order to refresh your minds about it. So let's see what are these 2 or 3 or 4 tools. Really the model isn't going to become that much more sophisticated than what it is right now. But the next step is going to present a model in a much more realistic manner. And so we're going to adjust a little bit what we have done up until now. The important thing is really the production possibility curve. Now, the production possibility curve, as we have discussed before, really rests, at least the shape, on an assumption. The assumption that we've made so far, if you still remember, is that of constant opportunity cost. Now, the other assumption that we're going to start making as of next week, and that's why we're going to introduce it right now, is that of increasing opportunity cost. Now, the assumptions for the model, for the rest of the models, are really the same. And again, let's take advantage of this opportunity and emphasize one more time that in any field, not only in economics, whenever you want to build a model is always going to be based on a set of axioms, on a set of assumptions. So what are the assumptions? What the assumptions, obviously, usually, because we are going to try and concentrate on geometric representations, is that we're going to be dealing with a plane. So a plane limits us to only 2 variables. Although very many of these models are really based on much more than 2 variables, but we have to make that assumption that it's 2 variables. And it really isn't a great big restriction, because again, let me say this for the umpteenth time, whatever is true of 2 in these particular cases can be shown to be true of n. So it is easier to do that particular assumption for the sake of presentation, but it is not a great big distraction from reality. So we will assume that you have two goods then. Then the other assumptions that are probably very familiar to all of you, since we've spoken about them before, is that you speak about full employment, because you see, all of these models have got to assume that society is already fully employed, because if it's not fully employed, then it means that it has the capability of growing without even anything else, without, for example, international trade in this particular case, or whatever the case might be. So you always have got to assume that the economy is already at full employment in order to try and demonstrate what is it that would happen once you reach full employment and yet you want to grow. Because if you are at full employment, then you're not going to be able to go ahead and produce any more of what you have. And that is where international trade comes in. It will allow you to have more given the same level of resources and the same level of technology. So the other thing is that we assume that the resources are constant and given. The resources are constant and given. And technology, which is often referred to as the state of the art, so technology is also constant and given. So given all of these things, what do we wind up with? We wind up with what we have demonstrated so far a number of times, a straight line production possibility curve. And that is what allows us to speak about what, by the way? This is what allows us to speak about the 100% specialization. So had it not been for this, then the 100% specialization doesn't come in. And so both for the absolute advantage and for the Ricardo model, we assume the constant opportunity cost, which allows us to do this. So let's assume that we have over here guns and wheat. So we know all the resources, we know how many guns we can produce if all the resources were devoted to guns, and then we would know how much wheat we can produce if all the resources are devoted to wheat. But we also know that probably no society is going to produce only guns or only wheat. And so what are the various combinations? If we assume that it's a constant opportunity cost, then this will be a straight line. What are the implications of a constant opportunity cost of a straight line? It means that the first unit will cost as much as the second, as the third, as the fourth, if this was drawn correctly. So the cost doesn't differ. You will have to give up some of one in order to have more than the other, but that ratio will be constant all throughout. Now, this is not realistic in the real world. When you look at society, you find out that the world as we know it, that as you shift resources from one kind of an occupation to the other, then it will become less productive. If it becomes less productive, what does that mean? It means that what you are shifting into is going to become more expensive. And that is when you have the increasing opportunity cost. So an increasing opportunity cost will make the production possibility curve concave to the origin. So over here we will have our guns, and over here we have our butter, or wheat for that matter. Which means that the first unit of wheat is the least expensive in terms of guns. The second unit will become more expensive, the third unit more expensive, the fourth unit more expensive, and so on and so forth. And that's why it's an increasing opportunity cost. So one more time, I can have more of one by having less of the other. But as I keep on increasing what I want to move into, they're going to become more expensive and more expensive and more expensive. Now the implication of this increasing opportunity cost is the fact that, as you said, as I've already hinted at, it means that we're not going to be able any longer to speak of a 100% specialization, as we'll find out next week. Now, as important as this is, we're using this really in order to speak also about another aspect that is hugely important in microeconomics, and you'll find out its application in this particular case. And that is the consumer behavior. Because as I hope all of us know, that ultimately it's your behavior and mine that are going to determine how this society is going to allocate its resources. That's to say, we produce a particular good only because of the behavior of the consumers. If the consumers did not allocate the resources in order to purchase that particular good, then our society would not be allocating resources in order to produce that particular good, and so on and so forth. So if we want to understand the dynamics behind all of this, we've got to understand how is it that the consumers behave. If you say that there is no law that's going to be applied in this particular case, then it becomes a hopeless case. And obviously we are trying to study it only because we believe that there are certain laws of motion that determine, that will allow us to know how is it that consumers behave. But again, there are sets of assumptions. So one of the most important ones, which again we've already mentioned before, is that of rationality. So the consumer is rational. You don't have the right to say that you're not rational, because the consumer is going to have to act in a particular way in order to maximize her utility. So what is it that we maximize as consumers? We maximize our utility. Furthermore, how do we measure our utility, our satisfaction? We measure it in terms of utils. So we create the fiction that there is such a unit that's called utils, which is what measures our satisfaction. Then the other thing that's important is that we speak about total utility increasing at a diminishing rate. The implication of this, again, are very strong. All what it means is that as you increase your consumption of any commodity, whether it be clothing, whether it be education, whether it be housing, whether it be food, whether it be drink, the first unit is usually the most valuable because it contributes the most. That's what this means. So one example that I like to use, you've run a marathon, you are practically dehydrated, you're very thirsty, so you'll pay, let's assume, $10 for the first drink, for the first glass of water. The second one is not going to be as important, but you might be willing to pay for it, let's assume $5, because you still feel that you can still use another glass of water. But now, if you've had your full, you're not going to pay anything for the third. And if they really force you to have the third, maybe they'll have to pay you for it. That's to say, there is a disutility. So this means that utility, in essence, really increases as you increase your, if this is, you're measuring utility over here, it increases, but it increases at a decreasing rate, which means that you will hit a maximum and then you will start declining. Now, if you put all of these together about the consumer behavior, what can we therefore arrive at a law that we're going to have to not violate in order to be able to speak definitively about consumer behavior and consumer maximization of utility. If you reflect on the subject for a few minutes, you'll find out, yeah, there is a very simple law which says that the marginal utility that you're going to get from A over the price of A, which means what, by the way? The marginal utility per the dollar that you spend on it, right? Is going to have to be equal to the marginal utility that you get out of another item over the price of that other item. In the real world, if you're going to be practical, you don't have only two goods, so this will be true for n goods, to the marginal utility of n over the price of n. Now this makes lots of sense, doesn't it? I mean, if you stop to reflect about it, what do you find out? Let's assume, for the sake of the argument, that the marginal utility here is 6 per dollar, and over here it's 9. You have that income of yours, and you've spent it. Now the income that you have spent, if this is where you stand right now, have you done the most that you can do in order to maximize your utility? Have you been a rational person? And the answer is no. Why? Because what can you do over here? You can switch some money from here to here. What's the rationale behind this? I'm waiting because to give you some time in order to reflect on this if you haven't. Because a dollar spent here is going to give you 6 units, while a dollar spent here is going to give you 9 units. So by shifting a dollar from here to here, you're going to increase your level of welfare by 3 units. But since this is increasing utility at a decreasing rate, as you're going to consume less of this, the marginal utility is going to increase. As you increase your consumption of this, the marginal utility per dollar is going to drop. So you keep on shifting from one to the other until, let's assume, both of them are equal to each other. Once this is 7 and this is 7, then there is no longer any room for any allocation, any reallocation, in order to maximize your utility. So really all what we're saying is that consumers in general are always doing this, whether you're spending, I don't know, $5,000 a week or $50 a week or even $500,000 a week or whatever it is. We are always allocating our resources by acting rationally in such a way as to equate the marginal utility per the last dollar spent. Let me take the opportunity again of mentioning one other small example just to make sure that this is clear for all of you. Let's assume, for the sake of the argument, something similar to games that they used to use in order to arrive at this theory in labs. So let's assume that I give, or Pace gives each of you a $20 credit, and they ask you to go into the cafeteria and buy your lunch by spending all of the $20. As you probably already know, it will be difficult to find any two students that are going to wind up with the same combination. This is all what this is saying. It's saying that those who prefer, say, red meat are going to wind up with a steak because they derive more marginal utility per dollar than those that prefer, for example, vegetables, or those that prefer fish. And so you wind up with a different entree and with a different drink and with a different side dish and what have you. And you do that in such a way as to equate the marginal utility per the last dollar spent. So this is not saying that all of us are going to wind up with the same allocation. Actually, it's exactly the opposite. This is saying that we're going to wind up with completely different allocations in order, though, to make sure that we don't violate this principle. We always act indirectly, without really thinking about it, not that we go around with a calculator and we do all our allocations in order to satisfy this particular principle. Now, there's nothing wrong with this principle, as you can see. Actually, it's the principle that has been used for a very long time, and even up until now, except for one thing, we had to modify it a little bit, because there is a flaw, a very fatal flaw in this. I hope some of you have already noticed that. What is that fatal flaw? I am assuming that you can measure utility. But as I've already indicated earlier today, by mentioning even the word, I use the word fiction. It's fictitious, this utility. So there is no such unit. You cannot see it, you cannot touch it, you cannot weigh it, you cannot experiment on it. It's a fiction only. So is it fair then to go ahead and build a whole theory on fiction? Well, there's nothing wrong with it. I mean, when we speak about very many theories, even the natural sciences, sometimes you have to make certain assumptions about how things work. And in this case, the economists made the assumption that this is the way that things work, but they weren't totally satisfied. They wanted somebody to come later on with a new additional twist to prove the same thing. So the conclusion is not going to differ, by the way. That's the important thing. And we did come up with that twist. So right now, whenever we speak about consumer behavior, we no longer speak about this theory that we have just described, because actually very often it's described as the naive, simple theory of consumer behavior. The new thing right now is known as indifference curve technique. So the thing that you're going to ask me probably is, what's the difference between them? Well, the difference between them really rests on two words. And the book, you've got to give him credit, because very many textbooks do not mention this, has mentioned both words. There is a difference between something that is cardinal and an ordinal measure. If I ask you to go ahead and rank the students in the class by height, you go ahead and measure every single student and you know exactly how much each of them, what's the height of each of them, and then you rank them. If you're going to rank them by weight, again you go ahead and find the exact weight of each student and you'll be able to rank them. If I ask you what is the width of a classroom or the room where you're sitting right now, you can go ahead and get a particular yardstick and you can measure it and you find out exactly what is the width of that particular room and so on and so forth. But what if I was going to ask you to go ahead and rank, or be a judge where there is a beauty queen contest? How do we judge a beauty queen contest? Well, there are no measurements. And that's why every single judge might wind up with a completely different kind of ranking. That is ordinal. That's to say, you rank things according to preference. So you rank things according to a preference. Another example, by the way, that is quite common for this would be the example when we go ahead and award all of these ribbons during county fairs. We award ribbons to, I guess, all sorts of things, from pumpkins to jam to cows to pigs and what have you. And what's the judgment? Well, every single person who is on that particular committee will have a completely different way of ranking them. But then ultimately you go ahead and agree on a particular procedure in order to choose a combination that will favor one vis-a-vis the other. So the economists have come up with the same thing. They said, okay, we're not comfortable with the idea of measuring cardinally utility. We're no longer going to deal with that. What we're going to deal with is ranking of levels of satisfaction. So right now, when we look at these two goods, we're going to come up with this. We're going to make this assumption right now. Again, by the way, we're going to be talking about two goods. We're going to say that there is a locus of points of these two goods, whatever they are. Let's go back to our traditional example, guns and wheat. And all of these combinations of guns and wheat yield the same level of satisfaction. And this is where the word indifference comes from. That's to say, if I give you a choice between 1 or 2, you will be indifferent. You say, hey, I don't care. If you give me 1 or 2, I'll take them. I'll take any of them. What about 3? Well, again, the same thing. What have you done, by the way? What is common between them? Over here, I have this much G and this much W, right? When I move from 1 to 2, what have I done? I've given up this much of G in order to gain this much of W. And if I move from here to here, I give up, by the way, this much more of G in order to gain this much of W. And so in the back of my mind, I am indifferent. It doesn't make any difference to me whether it's this or whether it's that one. Any of these combinations will do. So there are an infinite number of combinations that represent the same level of satisfaction. I mean, that is simple enough. But in order for this tool to really become helpful, we're going to say not only this, but we're going to say that there is an indifference curve through every single point of this quadrant. That is what is known as dense. So you'll have this indifference curve, this indifference curve, and this indifference curve, and this indifference curve. Now, call them obviously I sub O, I sub 1, I sub 2, I sub 3, and so on. I am indifferent only along one indifference curve, but I prefer one to the other. Which one I prefer? Remember, since I'm a maximizer, I always prefer more for less. So if I draw any ray from the origin, I would prefer the one that is furthest away from the origin. So anything on I sub 1 is preferred to anything on I sub O. Anything on I sub 2 is preferred to anything on I sub 1, I sub 2, and I sub O, and so on and so forth. So this way, I am no longer saying that this represents 5 utils and this represents 10 utils and this is 20 utils. I don't care how much does it represent. All what I'm interested in is that I prefer anything over here to anything over here. And I prefer anything over here to anything over here. Now, if I prefer something on I sub 2 over I sub 1, and I've already indicated that I prefer I sub 1 over I sub O, then by definition I prefer I sub 2 over I sub O. This is what's known as transitivity. If you prefer A to B and B to C, therefore you prefer A to C. Now this has a great implications for the graphical representation of this model. This implies, by the way, that there is no way that these can cross. So they do not cross. The indifference curves do not cross. Because if they cross, then they would violate this principle of transitivity. The other thing that is going to be very crucial is that we're going to call this rate of change, as you move from 1 to 2 to 3, you're giving up some of guns in order to gain some of the wheat. So this rate of change is going to keep on changing, right? Because this is not a straight line. This is a convex curve, right? It's exactly the opposite of a concave to the origin. It's a mathematical relationship, but we're not going to worry about it for our purpose right now. The only thing that we care about is that it's a convex, that's to say, it's exactly the opposite of a concave. So this is the way that it is going to look, right? And we're going to call this the marginal rate of substitution. That's to say, the rate over here is different than it's here, it's different than it's here, it's different than it's there, right? Those of you who have a slightly stronger background in quantitative analysis in math, let me just mention it for the sake of it. What is the rate of change at a particular point? It's the tangent, right? It's the slope. So it's the slope of the tangent. As you can see, every single point is going to have a completely different tangent, and that is what's known as the marginal rate of substitution in this particular case. How much we're going to give up of one in order to gain one of the other. So it is downward sloping, as you can see, and that again indicates that it has a negative slope. Technically, if you're going to go ahead and do the math, the marginal rate of substitution is really the marginal utility of one over the marginal utility of the other. And that will become helpful in a minute, as you'll find out. The other thing about this is that they can never be, by the way, backward bending. As soon as they become backward bending, you just chop them off, because the theory will fall apart if you're going to assume that this is going to make a bend like this. You don't allow it to make a bend. So your indifference curves are therefore these combinations, the various combinations of the two elements, or of the two goods, that yield the same level of satisfaction. They are not allowed to cross, they are dense, and the marginal rate of substitution is negative, that's to say, it is downward sloping. Now let's go back right now to our proverbial consumers that we've been talking about so far. What is the basic limit for a consumer? Why don't you go ahead and buy whatever you want to buy of any particular item? Well, because there's a limitation. What's that limitation? The major limitation, obviously, is that of income. So the consumer is always limited by income, which will allow us to go ahead, again, if we're speaking only about two goods, since we're going to be using a geometrical technique, a budget line. So you know, that's the idea of a budget. You know what is it that you can afford and what is it that you cannot afford. So let's assume, for the sake of the argument, that your income is, say, $100. And this good over here, G, has a price of $10. So how many G's can you get? 100 over 10, so you can get 10 G's, right? What if you don't like the G's and you want to buy the W's? How many W can buy? Well, you have to find out the price of W. So let's assume that the price of W is, I don't know, make it 20. Then I can buy only 5, right? 5W. So you can either buy 5W or 10G or any combinations in between. This is known as your budget line. Now, one more time, this is really similar to what? To a production possibility curve, however, on a personal level. That's to say, you're saying that this particular individual, given this income, can never buy anything outside this line, right? The maximum that you can do if you're going to spend everything is to be somewhere along this line. So where are you going to be? How do you know which of these infinite combinations is going to maximize your satisfaction? Who's going to tell me? Well, I mean, I know you can't tell me, but I hope you've arrived at the conclusion, because really it's very straightforward. Let's assume that you have this consumer has this indifference curve, and then you have this indifference curve. Immediately you know that there's nothing that you cannot afford this indifference curve. So this is really out of the question, because it's totally outside. Now this, you can afford this point, and you can afford this. But are you maximizing your satisfaction? And the answer is no. Why? Because remember, the indifference curves are dense. There's going to be another indifference curve, another indifference curve. So there's going to be an indifference curve somewhere that's going to be, let's assume, like this. Just barely touches. So this is the one that maximizes your satisfaction. This is the one, in the naive theory, is what the marginal unit of A over the price of A is equal to the marginal unit of B over the price of B, which is exactly the same. Now let's find out if it's exactly the same. When you look at this I sub 1, what did I say earlier, only 5 minutes ago, is the slope of this indifference curve at any point? It's the marginal utility of one over the marginal utility of the other. And what is the slope of the budget line? The budget line, which is a straight line, as I hope all of you know, is going to have a slope of the price of one over the price of the other. Now, the question is there any difference between this, which is the most sophisticated way of speaking about consumer behavior, and what we spoke about earlier, which is what? To remind you one more time, mu of A over the price of A is equal to mu of B over the price of B. Is there any difference between these two? And the answer is no. Cross multiply and cross multiply, you'll find out that they are exactly the same expression. So what have we done right now? We've arrived at a more satisfying way of explaining consumer behavior without really having to resort to that assumption that we know how to measure utility, which is a fictitious thing. And how did we overcome that? By using indifference curves, i.e. ranking. And you'll find out that this really has become probably one of the most widely used ideas in the whole of economics. Actually, you'll not be able to talk about welfare, about levels of equilibrium, about international trade, without using that notion of indifference curves. As you can see, the step or the jump from here to that of a country isn't really very big, because what is a country made out of? It's made out of millions of citizens, millions of consumers. So if each consumer behaves like this, I don't want to one more time put the cart in front of the horse, talk about it today, we're going to talk about it next time. But we're really going to assume that we are allowed to jump from the consumer to the greater society by summing up all of these things. And so we're going to be able to present the level of equilibrium for a particular society in terms of a communal indifference curve and the production possibility curve. Because the production possibility curve tells us what is it that the country can produce, and the communal indifference curve tells us where is it that the country, what are the combinations that will render a certain level of satisfaction for the citizens of their society. And the point whereby they are tangent to each other, that is the point of equilibrium. And the question then becomes, can we do anything through trade to go beyond that particular point? And as you might have already guessed, the answer is going to be yes, otherwise we wouldn't be raising the question. That's why really we believe so much, at least in pure theory, in terms of international trade. But before we leave this, we're going to have to do a couple of more things. And they'll be very quick and very brief, so it's not going to take a long period of time. But let me just tell you that we need to introduce two more things instead of consumption, though, for production, because if we don't get a chance to use them next week, we will use them for the week after. And this will be maybe the last major tool that we're going to need for a relatively sophisticated graphical representation during week 6. I doubt it that we'll do it next week. We'll do it probably in week 5. Okay, so what are we going to be doing over here? The same idea of the indifference curve is going to be used, but we're going to call this isoquant. Iso means what? It's the same, right? So it's the same quantity, isoquant. So we'll, instead of talking right now about two goods and the consumption, we're going to be talking right now about two inputs. So we're going to say that we can produce, let's assume for the sake of the argument, 10 units of whatever that gizmo is. So the difference between this and indifference curve is that right now we attach units. We know that I'm producing 10 units, but how do I produce them? I can produce them through using this combination of capital and labor, or this combination of capital and labor, or this combination of capital and labor. What does it mean, by the way, if I move from A to B to C? I'm moving from more capital intensive to less capital intensive to less capital intensive. So I'm becoming more labor intensive. On the other hand, if I were to move this way, I'd be moving from less labor intensive to more capital intensive, right? And why would a particular process of production move one way or another? What's going to be the single most important determinant? Obviously, you've guessed it, it's the price. So as the price of labor relative to that of capital increases, then you will move towards more capital-intensive means of production. A very good example, by the way, is the car industry. We produce right now more cars than we did around 30 years ago, with probably less than half of the employees, because the wages of labor went up so much that the process has become more capital intensive. Another very simple example, without really doing the math, we're not going to bother with the math for this course, but let's assume that you're talking about a particular infrastructure project. If you run across such a project, let's assume in the county of Westchester, what are you likely to find? You're going to find, let's assume, a workforce of 20 men, and unfortunately most of them probably are men in this case, and they will be using, say, for the sake of the argument, $50 million worth of machines. If you go to, I don't know, say, Cairo, they could be doing the same, a project very similar to that, and with the same quality. So we're not going to say right now of an inferior quality, but since the price of labor is much cheaper there and the price of capital is much more expensive, you're going to find out probably, let's assume, $5 million worth of machine and 500 laborers. So which is the combination that must be used? Well, we will use the isoquant and something similar to the budget line, but the budget line, we're going to call it the isocost. That's to say, you're a manager of a particular enterprise, and they give you $1 million. Or I say, let's become a little bit more realistic over here for our purposes and say $1,000. So that's your budget. And they tell you that you're going to have to hire capital and labor. The price of capital and the price of labor, say that this is, I don't know, 10 and this is 5. So what are the possibilities right now? The most that you can do is to spend all the money on capital, and then you'll wind up with 100 capital, right? If you go ahead and hire labor, you're going to wind up with, say, 200 laborers. What are the various combinations of capital and labor? It's going to be this straight line, right? Now, which of these are you going to use? Well, you're going to, right now, go ahead and superimpose your isoquant. So you have this isoquant, and you have this isoquant. You know, from what we've said, is that there is a level of output that is related to each of these isoquants. But it goes without saying that this one represents more than this. So if we're going to assume that this is 10, this might be, let's assume, 20. So would you use this? Or this? Or this? Let's just limit ourselves to these three. If you are a rational manager, and remember, we assume that you're a rational manager, you must choose two. Because why would you spend $1,000 in order to produce only 10 goods? If for the same money you can produce 20 goods. And the same thing about here. Why would you choose this when you can choose this? So the rational person will choose this. What is true about this? It's exactly what we said earlier. Right? It's the tangency between the isoquant and the isocost, which is, for production, really similar to the tangency between the indifference curve and between the budget line for the consumer. Now, let me just give you a very, very brief idea what we're going to do. So the next level right now is to go ahead and move from the Ricardian model to speak about the Heckscher-Ohlin. And we'll talk about it next time in great details. But the Heckscher-Ohlin is going to make use of all of these tools. The diagrams, though, are a little bit more difficult because of this idea that they're no longer a straight line. And so I might have to try and put the diagrams on the board ahead of time so that they will be sort of neat and explain the idea, or maybe I'll just try to blow them up and just show them on a piece of paper or whatever. So I'll figure out something for next week about that. But when you read the chapter, the next chapter, you have to pay attention to all of these models, because they are really very important in understanding the dynamics. And once we do that, by the way, and then we speak a little bit about some of the implications and some of the other newer theories, but none of them as major, then that's it for theory. So after midterm, we'll immediately start talking about policy, which becomes really totally descriptive. And depending on how much time we have, I think if we're going to stick to the syllabus, and I think we will, we have given the finance only either 2 or 3 weeks. So we're going to be very limited really to the idea of the macro, which is probably the most complicated part. But as you can see, by the way, half of the course is really micro. Because really micro is an application, or international trade theory is an application of microeconomics for all practical purposes, right? So we're going to use all of these tools in order to move ahead and speak about the next step, and it's the final step. But the thing to keep in mind, and I will probably reinforce it next week and maybe the week after, and maybe the week after that, is that the heart of the model, whether it's the sophisticated one or not, is really Ricardo. We never give up on Ricardo. Everything is based on that idea of comparative advantage. But we try to present it in a slightly more modern way, and in a way that answers some of the questions that he wasn't able to raise. So with that, I will let you go, and I'll talk to you next week. Bye-bye.